All right, guys, we are going to go over I'm making this video just in case live streaming the review does not work very well. So number one, you're naming a plane parallel to plane WXT. WXT is this. It would be this front rectangle right here. Remember, we talked about this. They use 3 letters. You can use 3 letters, or you can use however many corners you have in that plane. So this would be, WXTS. Well, go to the plane parallel to that rectangle, and that would be this skinny little rectangle back here, which would be plane VUZY, or any combination of that letter. Remember, you could just list 3. 3 is fine. Number 2, list 2 segments, or name 2 segments parallel to VU. VU is right here. Parallel just means they never intersect, so you've got VU would be parallel to either ST, ZY, or WX. You could have listed any of those 2. Well, any 2 of those 3. There we go. Name 2 segments parallel to SW. SW is right here. That would be VZ, UY, or TX. 2 segments skew to XY. Remember with skew, we went, all right, XY is right here. That's this one. I can't do any of the intersecting, so not this one, and not this one, not this one, and not this one. I can't do parallel, not this one, and I can't do ones in the same plane, so not this one, which means I can list VZ, I can list SW, I can list VS, I can list VU, and I can list ST. You had 5 different options there. 5, 2 segments skew to VZ. VZ is this back one. No intersecting, so not VU, not VS, not ZW, not ZY. You cannot do parallel, so not SW, not UY, not TX. And once you've taken out that one, that one, that one, that one, that one, that one, oh boy, where did I go? That one and that one, you're left with ST, WX, UT, and YX. Man, that figure got sloppy. Sorry about that, guys. Hopefully my document camera will be here on Tuesday, and that's going to make life, slightly easier for me. All right, 6 through 10, you are naming the angle pair relationship and which transversal. So angle 4 and angle 10. Angle 4 is right here, angle 10 is right here. They're on the same side of the transversal on the inside. That means they are consecutive interiors, and your transversal would be line K. 8 and 11. Where's 8? 8 and 11. Those are alternate exteriors, one on the left, one on the right, opposite corners. And that transversal that cuts down through there would be M. For number 8, 2, and 12, 2's here, 12's here. There's no relationship there. They're not alternate, and they're not consecutive interiors. So 8 is no relationship, therefore you cannot have a transversal. Number 9 is 5 and 7. One of the ways to remember this, because 5's on the outside, 7's on the inside. The only way you're going to have one outside and one inside would be if they're corresponding, or, that's in the left corner, left bottom corner, that's in the left bottom corner. The transversal that cuts through there is J. And then lastly, 2 and 13. 2 is here, 13's here. Those are on opposite sides of the transversal, opposite corner, and they're between the 2 lines. So those are alternate interiors, and the transversal is line L. So that's just classifying the relationship. Then we come down here and we say, okay, now they're parallel. So now if our things are parallel, if our lines are parallel, then that means we either have congruent angles or we have supplementary angles. Your congruents are corresponding alternate interiors and alternate exteriors. Your supplementaries are consecutive interiors. So number 11 is pretty simple, and I've got a whole hodgepodge here, and that's difficult to read. I understand that. The measure of angle 7 is 131. So 7 is 131, 1 is 131 because those are vertical. Then you had to remember P and Q are parallel, which means line R is one transversal. So 7 corresponds with 5. 5 is 131 and 3 is 131. To find any of the rest, meaning to find 2, 4, 6, and 8, you had to do 180 minus 131, and that gave you 49 degrees. So that's angles 1 through 8 taken care of. Then these set of angles back down here, those came off of transversal S. So once you have that 16 is 88, 16 is 88, 10 is 88, 14 is 88, 12 is 88. Via, verticals, these are corresponding, these are verticals. Then to find one of the other ones, you have to do 180 minus 88 to get 92. So 9, 15, 11, and 13 are all 92 degrees. So that table is all filled out for you. Again, on one of the transversals, you either had 131 and 49. On the other one, you either had 92 and 88. Those were your only options. Now, for number 12, we're going to go over how to do number 12, big style. So number 12 gave you the angle 2 was 63 degrees. It gave you that this line right here is parallel to this bottom line down here. Parallel lines means things are either congruent or supplementary. And then the measure of angle, well, we'll go with what we got. If 2 is 63, that means 5 is 63 right off the bat. Those are vertical. There are no, because this is a crossroads of two transversals, we can't do corresponding and we can't do anything else. So that's all we can do with that piece. The other piece of information you're given is that the measure of angle 9 is 105. Well, if 9 is 105, then 7 is 105 because they're vertical. Then, let's see, let's make this a little bit darker. 105, 105. All right, if this is 105, that corresponds up here to this entire angle. Those are in the same position, which means to find 4, we've got to do 105 minus 63, and that gives me 42 degrees. So 4 is 42 degrees, which means 1 is 42 degrees. And then, all right, we're going to hop back over here for a second. To find 10, well, everybody see the straight line there? 180 minus that 105, that gives me that 10 is 75 degrees. If 10 is 75, then 8 is 75. Then I can take this angle, 2 loops there, and drag it up here because it's in the same spot as number 6. So 6 is 75 and 3 is 75. So that takes care of this cluster and this cluster, but now, we still got to do this cluster. So if you look at this transversal that comes down through here, if you notice, 42 is between, your parallel line, the transversal. So 42 is an interior, which is alternate interior with that. That would be 11. So if 4 is 42, 11 is 42. If 11 is 42, then 13 is 42 by verticals. And then, to find 14, 180 minus that 42 to get 138 degrees. And if 14 is 138, then 12 is 138. So I'm going to slide this over here in case you want to look at that and pause your screen for a second, but that's the answer key just all filled out instead of hodgepodge together in one spot. So your next page, let's see, 13, you've got to, hang on, directions first might help. You're trying to prove that these lines are parallel. Nope, I'm wrong again. Find the values of x and y if they're parallel. So we know these are parallel. That changes things. Knowing that these are parallel, you've got x's and y's. We start with which variable we have 2 of. We have 2 x's. Our 2 x's are alternate exteriors. And I know for a fact on your test or your quiz, you're taking a quiz, I'm asking you to identify what you're using. So alternate exteriors are congruent. Congruent's another word for equal, so we set them equal and we solve, we get x equals 9. So if I take my 9 and I plug it back in, well, 8 times 9 is 72. 72 plus 1 is 73. That means this angle right here is 73 degrees. Well, y is right here. So these two angles combined have to equal 180. So I can do, 6y plus 29 plus 73 equals 180. Or I can say, all right, if these two are 180 and this side's 73, that means this side has to be 107. I know some of you would prefer it that way, and I'm fine with that. So you would set up 6y plus 29 equals 107, and you would solve it from there, and you're still going to get the same answer. Number 14, again, you've got two x's first. Your x's, in this case, bottom right corner, these are corresponding. Corresponding angles, again, are congruent, so we set those equal, and we end up getting x equals 22. So take your 22, plug it back in. Is 7 times 22 is 154. 154 minus 30 is 124. So I can do the 3y plus 11 plus 124 equals 180. That's perfectly fine. Or I can say, all right, if this side is 124, then this side has to be 180 minus 124, which is 56. So 3y plus 11 equals 56. And then, solve it and you get 15. Number 15, again, x's first. Now, these two x's, they're in between. If they're in between, that means they are consecutive interiors, and consecutive interiors are the only ones that are 180 degrees. Which means 23x minus 16 plus 8x minus 21 equals 180. You get x equals 7. Where I would plug this in is right here, because these two angles are vertical. Vertical angles are congruent. 23 times 7 is 161. 161 minus 16 is 145. So that angle is 145. So 7y minus 23 equals 145. Add your 23 to both sides, y equals 24. A lot of that is knowing what angles are congruent, what angles are supplementary, children. That's really all you need to know for those. Number 16, given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. So 18 and 20, no, that's an 8. 8 and 20. 8 and 20 are alternate interiors, and they're alternate on line X and line Z. So X is parallel to Z. That's your alternate interior angles converse. So point-wise, this would be a point. This would be 2 points. One for correctly identifying this and one for remembering the converse. So make sure you remember that converse. Otherwise, you're missing silly points. Angle 1 and angle 9. 1 is in the top left, 9 is in the top left. That means they're corresponding. So you use your corresponding angles converse to prove that line X is parallel to line Y. Oops, sorry, move that. No, this eraser does a poor job. 3 and 10. 3 is here, 10 is here. So 3 and 10 are supplementary. Well, those are in between, which means they are consecutive interiors, and your consecutive interior angles converse would prove the line X is parallel to line Y. D, angle 11 and angle 16. Well, 11 and 16 are on the same side on the inside, which would prove M and N parallel if they were supplementary. That's saying they're congruent. Consecutive interiors are not congruent, they're supplementary, so this is a none. 14 and 23, 14, 23, those are alternate exteriors. I do understand that 14 is on the inside of these two lines, but if we're talking about line Y and Z, 14 is on the outside, 23 is on the outside. So Y is parallel to Z, alternate exterior angles converse. F talks about 4 and 21. Well, bottom left corner of line X and line Z. So X is parallel to Z, corresponding angles converse. G is 8. 8 here and 18 here. Those are on completely separate transversals, and I tried to get that through your head. If they're not connected by a transversal, it's a no-go, so that's a none. And then 5 and 15, your last set of angles. 5 is here, 15 is here. Outside, outside, opposite sides, so alternate exterior angles converse on lines X and line Y. Moving on. Number 17, 8 and 18. Find the value of x that would prove j parallel to k. So this is where we're trying to prove them congruent, and we need to identify which converse we're using. Well, that 14x minus 25 is this angle, and the 129 is this angle. Opposite sides of the transversal in between your lines, which means alternate interior angles converse. Set them equal, solve. Number 18, however, let's see, that's that angle right there, and that's that angle right there. So those are in between your two lines. If you've got in between, that means you've got a 180. Those are consecutive interior angles. Consecutive interior angles are always supplementary. Add it up, set it equal, you get 18. You've got a couple of those, and again, 1 point for setting it up, 1 point for solving it, 1 point for consecutive interior angles, 1 point for remembering your converse. And then your proof. Your proof is on a completely separate sheet of paper, but this is a leftover review from last year since my printer hasn't arrived yet. So, given angle 1 is congruent to angle 2. So if you've got a figure like this, angle 1 is right here, angle 2 is right here. 1 is congruent to 2, go ahead and mark that. And M is parallel to N, you need to go ahead and mark that. You are trying to prove, oops, I just erased my 3. You are trying to prove that A is parallel to B. So the only angles, there we go. The only angles that are on A and B would be 2 and 3. So we need to prove that 2 and 3 are congruent. So start with what you know. Number 1 is given, number 2 is given. Or you can do what I normally do and shift everything up here into the given. That is fine. This was pulled out of something that I don't normally use. So 1 is congruent to 2. There's not much you can do on this figure with that. But M being parallel to N, there's a lot you can do with that. So come over here to your figure and focus on it for a second. M and N. If I look at transversal B, are there 2 angles labeled on transversal B? No, there's 1. Come up here to transversal A. Are there 2 angles on transversal A? Well, yeah, there's 1 and 3, right? So if I currently know that this is parallel to this, and this is my transversal, 1 and 3 are corresponding angles, and corresponding angles are congruent. So my step number 3 is that angle 1 is congruent to angle 3 by your corresponding angles postulate. You guys will not have to know whether if it's a postulate or not, simply because you don't know that. The packet didn't go over that. So you'll just write corresponding angles there. And then 4, because there's really nowhere else to go with that picture, now you've got to look. So if 1 is congruent to 2 and 1 is also congruent to 3, then 2 is congruent to 3, or if you think it this way, A is equal to B. If A equals B and B equals C, then A equals C. You remember the transitive property? So it's either transitive or substitution, either one. And coming back over here, 2 and 3, those are alternate exteriors. So your alternate exterior angles converse says if your alternate exterior angles are congruent, then your lines are parallel. So A is parallel to B because of this. Now, your proof on your quiz, I give you all of this. You just have to fill in your reasons. So if you have any questions, let me know.